Namaskar. This is Srinath Vasam, SG Mobile Regional Telecom Training Center. So, on the part of EPP examinations, the E4, E5 module. So, the consumer mobility module, the chapter number 1, we are going to discuss the basics of mobile communications. Okay, here we'll be discussing completely about a lot of nomenclature related to the mobile communications. So now here in this chapter we are going to discuss about the cellular concepts. So fundamentals of the global system for mobile communications and the GSM specifications. At the same time we'll be going in detail with the architecture, the GSM elements, functions and identities. Now coming to cell, what is a cell? Cell is basically the geographical coverage area of one base transceiver station. That is called the cell. So normally what we do is we deploy a low power transmitters throughout the geographical terrain, and the low power transmitters are giving us they are framing a cell, they are forming a cell on the geographical terrain. So now this cell is a basic geographical unit in the complete cellular communications. So now coming to that type of cells, we are having a couple of types of cells. Now here we will be discussing on the macro cell. What is a macro cell? Micro cell, pico cell, selective cell and an umbrella cell. Comes to the macro cell is a one which is having a larger coverage area, just like where we deploy, in the sense wherever we are having a lesser density of the population. Just like if we take an example of the rural area, we'll be having lesser density of our customer base. At the moment we are deploying the macro cell with larger coverage. So coming to the micro cell is having a smaller coverage. So in the sense, the same cell, if we deploy as a macro, right, it will be covering the number of users, more number of users in that segment. But but coming to the micro cell, it will be covering the lesser area, so that in the lesser area the objective is to cover the more number of users. So normally in the urban, what happens is urban cities and all, population will be more. When the population is more, so the people wanted to trigger the services becomes more. So at that moment, what we are doing is we are confining that area to particular segment. We are restricting that area. So in the sense, micro cells are having lesser coverage area. We are restricting the coverage area to give the the more services to the users, limited to that particular area. That is what micro cells. Now coming to the pico cells again having a very less coverage area. Just like if you assume that shopping malls kind of thing, Shara City Capital Mall or Inorbit Mall or all. So where we are having larger density of population, larger density of the customer base. At the moment, we wanted to give the services in a smaller areas, just like. So that is what we are talking about, the selective cells. Coming to the pico cells. So coming to the selective cells, so sometimes I just wanted to take an example here. For example, if you are going on a highway, if some tunnel is coming, right, we are entering into the tunnel. So now whenever such kind of scenarios are there, at the moment we wanted to penetrate, or we wanted to radiate our signal into a particular direction, just like into the tunnel. So then we will be deploying a selective cells. And the selective cells are giving the radiation or the signal into that particular duration, just like in into tunnel. Now comes to the umbrella cell. As the name says, in an umbrella it's a kind of protection. So what we are doing is we are deploying some cells, and above all these cells, so whatever may be the cell, selective, pico, micro or macro, what we will be doing is we will be putting an umbrella kind of cell with a larger coverage area. So what is the advantage are we going to get by using or deploying the umbrella cell is, see, in fact in the cells, in normal cells, what happens is, for example, a fast moving subscriber is there. So when the fast moving subscriber is there, what happens is rapid moving subscriber. So there are n number of handovers are triggering in particular when he is moving intercell operations. So when the person moving from one to the second to the third, and third to the fourth very frequently, so the load on the network increases, the handovers becomes more. So in order to avoid that n number of handover triggers, and in order to avoid that load, what the network is doing, network is giving an flexibility to take that rapid movements. So what we are doing is the users are being connecting. We are forcing the users to get connected to the umbrella cell. So now the rapid moving or the fast moving subscribers will be handled by that umbrella cell, so that we can deload the network, we can reduce the handovers which is happening in the network. That is the concept of the umbrella cell. Coming to the cluster, cluster is a group of cells, but basically the cluster is used in order to reuse the frequencies. Normally what happens, in our hand, when it comes to the GSM, so we are going with an FDMA concept where the band is divided into particular carriers, and we'd be getting the carriers. And if you are taking over the GSM 900 band, we'll be having 124 RFCs, absolute radio frequency carriers. So these 124 carriers are being shared among the users, operators, and the operators in turn, probably they might be getting around 32 or 36 something in their hand. So that 32 36 carriers has to be used. For example, you consider Hyderabad, such kind of cities, right, where we are having square kilometers of the area to be covered with the BTSs. So, but every BTS must be requiring a minimum of one carrier to in order to form a cell. So at the same time, the coverage area of one BTS might be coming approximately 900 meters or 1 kilometer hardly. So then these thousands of kilometers, to cover these thousands of square kilometers, we might be requiring thousands of the BTS, right? So but we are having only 36 carriers. We are able to provide only deploy the 36 cells. Then whatever the other geographical terrain. So that's the reason what we are doing is we are taking couple of carriers in our hand, and we are going into the cluster form, so that within the clusters the frequencies are different, and whenever we are using the same cluster beside to this cluster, the frequencies will be repeated. Like if you observe here, so on the last picture where the cell 1 yellow color is been given, so that cell 1, the cluster 1, cluster 2, cluster 3 is there. So the same cluster is been repeated, and 7 cells cluster is been repeated with the same frequencies which is there. If for example consider that frequency 1, RFC 1 is applied to the cell 1, RFC 2 applied to the cell 2, RFC applied to the cell 3, like so on. But here the question comes, so how many group of cells to be taken? Either I need to go for the 4 cluster, or I need to go for the 7 cluster, or something else. And at the same time, so what is my what is the criteria of should I have any kind of trade-off condition here? So now here we recall a principle called Q is equal to D by R is equal to root 3 N. So that N stands for the N is nothing but the cluster size, cluster size, and D stands for the distance between the cells which is having the similar frequencies. For example, here the distance is, so cell 1 in this cluster to the cell 1 and another cluster, and R is the radius of that particular cell. Now that depending on that Q, we will be deploying that sectors in such a mode, how many cells we are taking into that. If the Q value is more, when the Q value will become more, if the distance between these two cells, the co-channel cells is more, then the Q will be increased. Or if I reduce the radius of the cell, the Q increases. So if I Q increases, what happens is the co-channel interference decreases, in the sense signal to noise ratio increases, and at the same time my speech quality increases. So it is like we'll be going with some trade-off conditions, so that depending on the frequencies what is available in our hand, so basing on that we are going for the clusterization. And coming to the real-time scenario, so theoretically we would be we'll be considering the cell shape is in an hexagonal form, but practically it's not an hexagonal form, and we are deploying the cells to in the fashion of overlapping. Why to overlap? Basically because the cell may differ, the coverage area may vary depending on the atmospherical conditions and other factors and all. So whenever the cell the coverage area varies, so that if the person who is there at the edges in the cell edges, so may be covered by another cell or another BTS. Now let us have a focus on uh, increasing the capacity of the cellular cell. See, normally what happens is, see, when we are feeding one ARFC, it is forming a cell, and in that one ARFC, in the uplink direction and downlink direction, with implementation of the TDMA, we are getting 8 time slots. So what is the option left? We are having only one TDMA frame of 8 channels, so we don't have any other options. We have to increase the carrier. We need to add one more carrier to the cell. So instead of adding the carrier to the cell, what we are doing is the cell will be divided into sectorization, and each sector will be feeding one carrier. So that what happens exactly is, if the cell is divided into 3 sectors, for example, in the 3 sectors, I'm deploying one carrier in a sense. So in each sector, I am able to provide 8 channels. So included the complete cell, I am able to make it 24 channels. So like this wise, what we are doing is, in order to increase the capacity, I am going for this kind of splitting of the cell, or sectorizing. So and one more benefit of the sectorization is not only increasing the capacity, and at the same time we are able to have the optimum frequency reuse will take place, and at the same time, when it comes to the co-channel interference also, so we are able to reduce the co-channel interference. Now, these are the features of the digital cellular systems, just like small cells, frequency reuse, small battery or powered handsets, and performance of hours. So objectives, we all know this. Now coming to the evolution of mobile technologies, see, what is the main objective of the mobile technologies? Though we are having the PSTN network, we have started the mobile technology. So what is the objective behind it? So the main objective behind starting of the mobile technology is the mobility. So the user wanted to use the phone while on move, and he wanted to use the services while on his move. So that mobility object was satisfied in the first generation communications, and the first generation communications were purely analog in nature, and there the mobility was satisfied. And coming to the second generation, so the second generation is the first mobile communications with the digital standards. So here, we have started the stepping stone. We can treat it as a stepping stone, or the starting point of our digital mobile communications. And that standard mainly will be discussing about the GSM, Global System for Mobile Communications. So this is in brief with the technologies. You just you can go through that, the technology names and the throughputs in that particular technology and all whatever we discussed. Now coming to here, so ours is kind of duplex communication. The mobile is using a duplex communication, and there are two paths are available. One path, what we are talking about, the mobile station. So mobile station to the BTS or mobile base station. That path, the information going from mobile station or mobile to the network, we are calling it an uplink, and the information which is coming from the network to the mobile, we are calling it a downlink. Now here in the uplink and downlink, so if we use the different carriers, different frequencies which is separated for the uplink and downlink, then we call that kind of duplex methodology as a FDD, frequency division duplexing. If we are using the same frequency for the uplink and downlink, but on the same frequency we are sharing that information in different instances of time, just like in the T1 instance of time using the FA carrier, I am sending in the uplink, and in the T2 instance of time and the same carrier if I am receiving the downlink, so then we call that kind of duplexing methodology as a time division duplexing. So here we are having two kinds of duplexing methods when it comes to the mobile communications. One is an FTD method, another is the TDD method, frequency division duplexing and time division duplexing. Now coming to the technology wise, so all, whether we are talking about the GSM, CDMA, 3G and LTE, whatever, we are using the frequency division duplexing, but as far as the LTE is concerned, LTE provides an advantage to use even the TDD also. And coming to the multiple access techniques, so why are we going for the multiple access techniques? Basically because if we have some limited resource, one or limited resource, and those resources have to be shared among multiple users, just like an n number of users, then we are going for the multiple access techniques. Out of the multiple access techniques, the GSM uses FGMA combined with the TDMA, frequency division multiple access combined with the time division multiple access, and the CDMA uses the same CDMA, and 3G uses a WCDMA, wideband coded division multiple access, and 4G LTE uses not only OFDMA, orthogonal frequency division multiple access, it also uses a SCFDMA also. In the downlink direction OFDMA, and in the uplink direction SCFDMA. Now here coming to the bandwidth management, or we're talking of the frequency region. As we were discussed that GSM uses the two FDD, frequency division duplexing methodology. In a sense, we should have allocated a separate frequency region for the uplink, and we should have allocated the separate frequency region for the downlink. So that's the reason here when we are talking about the 2G spectrum, so the couple of bands are there. Out of that, here we'll be focusing mainly on two bands, GSM 900, that's also called PGSM, and GSM 1800, that's also called DCS 1800. Now if you observe the GSM 900 band, PGSM band, so that uplink frequency region is allocated from 890 MHz to 915 MHz, and the downlink frequency region is allocated from 935 MHz to 960 MHz. Now what is the bandwidth here? If you observe, the difference between 890 to 915 and 935 to 960, we are having 25 megahertz of the bandwidth. Now if you are moving to the GSM 1800, so that uplink frequency region has been allocated, so 1710 megahertz to 1785 megahertz, and the downlink frequency region is allocated 1805 megahertz to 1880 megahertz. Now if you calculate the bandwidth, so now the bandwidth is coming 75 megahertz. Okay. Now what happens here? I'll just take a example of the GSM 900. So this is of 25 megahertz bandwidth. So if we apply some FDMA concept there, so that 25 megahertz bandwidth is been splitting into the carriers and individual each carrier is having 200 kilohertz of bandwidth. So if you separate this 25 megahertz each with 200 kilohertz, normally we are supposed to get 125 carriers, but as carrier to carrier we need to leave some guard band spacing. So out of that, a 200 kilohertz spacing has been removed as a guard band together. So available number of carriers will become 124. That's what we are talking about, the RFCs, absolute radio frequency carrier number ends. So now what is happening? So that 124 carriers is available on the uplink direction of the 25 megahertz, and even downlink direction in 25 megahertz. So 124 carriers in the uplink direction, 124 carriers in the downlink direction. Now what's happening after the FDMA? We are applying a technique called the TDMA on individual carrier. So whenever we are applying the time division multiple access technique, we are going to get a TDMA frame, or we are going to get 8 time slots on one carrier. So these 8 time slots are being treated as a channels, and these channels are there, 8 channels are there in the uplink direction, and 8 channels are there in the downlink direction. Now these are the channels which are carrying the information to and fro. Uplink channels are carrying the information in the uplink direction, and the downlink channels are carrying in the downlink direction. So these are basically the physical channels what are available in the both the directions. I mean to say uplink and downlink direction, uplink channels in uplink, downlink channels in downlink. Now these physical channels are being treated as some logical channels depending on the application and usage, right? For example, if the channel is being using to transport the traffic information, then we are calling it a traffic channel. And if the channel is being used to transport the signaling information or the control information, then we are calling it as a control channel or signaling channel, right? So, and again in the control and signaling channels, we will be having a number of variety of these channels. So that is what. Now, as far as the mobile communication is concerned, the GSM is concerned. So now what has to be done in the mobile? So we are using some kind of encoding technique. The speech part has to be encoded to convert it into digital information. So that encoder what we are using is an RP LTP, regular pulse excited long-term prediction. Sorry, regular pulse excited linear term prediction. RPLTP stands for the regular pulse excited long term prediction. Okay, the encoder we are using there, and after that we are getting around 13 kbps of bitrate we are reaching, and when it comes to after adding the redundant data and after ciphering process and all, we are going to get a transmission rate around 270.833, and then we'll be modulating and we'll be sending over there, and the modulation technique we are using is a GMSK. Okay, similarly if you observe that carriers, so now that ARFC what we are talking about is one ARFC consisting of the two frequencies, one in the uplink direction, one in the downlink direction. So that duplex separation should be 45 megahertz if you are taking about the GSM 900 band, and if you are talking about the GSM 1800 band, the duplex distance or duplex separation will be 95 megahertz should be there. And coming to the carriers, so the GSM 900 is giving you 124, and the GSM 1800 it is giving 374 carriers. Now coming to the GSM architecture, so here, so the first element what we are talking about the mobile station. So why are we talking about the mobile station? In the sense, whenever we are purchasing the handset and whenever you are purchasing the SIM card from the operator, so we are inserting the SIM card into the mobile, and when we are switching on, after activation process, our mobile is ready to interact with the network. In the sense, it is able to send some information, and at the same time it is able to receive some information. So it becomes a station. So it is having a trans and it's having a receive. So it is becoming a station, and it is a moving one. That is the reason we are calling it a mobile station. So now the first element which is coming in the network where the mobile is interacting, That low power transmitter, we are calling it's a BTS in the 2G, right? Base trans receiver station. If you are going to the 3G, the same thing we are calling it's a node B, and if you are going to the LTE, we are calling it's an E node B, evolved node B. Anyway, as far as our is concerned, it's restricted to the GSM architecture. So the first element in the network is a BTS, and a couple of BTSs are being connected to one entity called the BSC. So base trans receiver stations are connected to base station controller, and together, so BTS and BSC part, we are calling it a BSS, base station subsystem, right? So now these kind of BSCs are being connected to an element called MSC, Mobile Services Switching Center, and this MSC is having connection with the signaling databases like VLR, HLR, AUC, EIR. HLR stands for the Home Location Register, Equipment Identity Register, EIR, AUC Authentication Center, VLR, Visitor Location Register. And coming to here, the VLR basically is a part and parcel of the MSC, part and parcel of MSC in the sense the VLR and MSC, they're functionally separate entities, but they are in the same physical node, right? And just have a glance and remember the interfaces also. So BSC to the MSC, we are calling it an A interface, MSC to the VLR B, MSC to HLR C, HLR to VLR D, VLR to other VLR G, MSC to other MSC E, and MSC to the AR F. Now GMSC is the gateway mobile service switching center, which is used as a gateway to interconnect with other PLMN networks and PSTN networks. So together all these components we are calling the network switching subsystem, NSS, and at the same time we are having OSS part, operation subsystem, so which is a combination of the OMCR and OMCS, operation and maintenance center radio and operation center for switch. Now the OMCR is taking a control of complete BSS part, and it's able to we are able to troubleshoot. We are able to remotely handle all the BSS elements for different kinds of management, like fault management, performance management, configuration management, all these things. Similarly, through the OMCS, we are able to do all these kinds of management for the NSS elements. Now let us understand the functions one by one. So before we go to the functions, so let us have something called the area-wise identities. Now we know that the BTS is giving you some geographical coverage area. That coverage area we are calling as a cell, and every cell is been identified with an identity called global cell identity. Global cell identity. Now when we are dividing, and I mean to say, so for example Hyderabad is there, and Hyderabad is being divided into particular locations here in the mobile network, and each location each location area is been identified with an identity called location area identity. Okay, and within that location area we are having couple of cells. So each cell we are having different identity called global cell identities. Now when we are supposed to say, taken an example like Hyderabad is divided into particular location areas and all, so you can assume that in Hyderabad is having one particular MSC, right, and within that MSC we are having a VLR also. So we'd be having an identifications, the global title for these elements, and at the same time this couple of MSCs are being deployed in one PLMN area. That's what we are talking about, one AP BSNL or Tamil Nadu BSNL or Karnataka BSNL and so on. So in the post MNP scenario, just you can say each PLMN can be identified with a location routing number LRN, and all these PLMNs processed in the GSM service area, nothing but the pan-India network. So now what are the importance of these identities is, for example, in order to identify a subscriber, in order to give a service to the subscriber, for example, you assume that if you are making a call to me, so what happens is the network has to find out where I am roaming, where I am situated. So if the network finds me where I am situated or located, then only the network able to page me a call, and it's able to give an incoming call to me, right? So in a sense, so there's the customer is a moving customer, and the mobile communication is meant for the mobility. In the sense, our network has to track the customer or identify the customer location. If it identifies, then only it is possible to give a service to that. In order to identify his location, we are using this kind of location identities. Chalo. Now coming to the BTS functions. So the BTS, what are the BTS functions? BTS has to track all the customers within the cell area, and whoever the rooms in the cell area, it has to support to, it has to give the services to that particular customers. So BTS provide the radio interface directly to that particular mobile, and BTS is connected to only one BAC. So one BTS cannot be, it's not possible to connect for multiple BSCs. And one more thing is, one BTS can have more than one number of transceiver stations also. So it performs functions under the control of BSC in order to coordinate that connections with the mobiles at the same time. Okay, so those are about the functions. Now coming to the BSC functions, see, as we discussed, so there are a couple of channels are coming from the uplink and downlink. Now in one particular cell, for example, there are couple of channels are persisted which is carrying the information, and depending on the application, those channels are being treated in different names. Now here a question comes, so which channel has to be allocated to the which user on what basis, right? So the decision has to be taken by one entity. That kind of, the management or the decision making management, we are calling the radio resources management. So that radio resources management is the main, very important function of the BSC, base station controller. In the sense, the BSC is taking care of the radio resources. What are the radio resources? Those channels, right? Management in connected its BTSs under its connected cell areas. So, and at the same time, it assigns and releases the frequencies and the time slots to all the MSs, and at the same time, so at the same times, it reallocates the frequencies to the BTS. Okay, so to meet that heavy demands during the peak hours and special events. And here I just wanted to say one more thing. So in order to to provide the security to the customers, so not only I mean, we are following some kind of frequency hopping technique. See, so apart from the frequency reuse, we are following the frequency hopping technique. What is the frequency hopping technique? In the sense, the frequencies are being changed dynamically, right? Dynamically. So now whenever the frequency changes, so who will be giving, this frequency has to be changed from this to this to this. So now this is only the BSC is reallocates the frequencies to the particular BTSs and all. And at the same time, another function is the power control mechanism function. See, for example, one user might be near to the BTS and he might be going far away to the BTS. So when he is near, what happens is, he is having the much more signal strength, and coming to the listening ability, right? The BTS is going to listen that MS in a good condition. But if the person moving far away from the BTS, when it goes to the cell edges, so probably the user may not get a signal strength properly, and coming to the BTS listening ability to the person who is at edge, it may be poor. At that moment, what happens is, now the BSC will be taking a discretion basing on the signal strength received by the mobile. So it is giving an input. So how much power you need to raise in order to reach your information, or in order to listen, in order to I should listen to you. Okay, जो मैं सुनना चाहे तो कितना power use करना है. If you use this much of power, then only I am able to listen to you. That is what the power control mechanism we are talking about. Now coming to the functions of the MSC. So we are all know that MSC performs the call management functions, and call management functions is not the call handling function, the routing of the call and everything. So, and one more thing is, MSC makes a location update process. It is an encryption and paging, resource allocation, So all these things, apart from that, as we seen in this last slide, MSCs get connected with all the signaling databases. So normally what happens is, for every service, there are three checks as mandatory. One thing is an IMEI check. So that IMEI check will be performed with the help of the EIR, and authentication, so which is performed with an authentication center, and the ciphering process is also done through the authentication center with the help of the authentication center. So these three checks are mandatory, and at the same time, whenever somebody is calling in particular MSC, for example, I am situated in Hyderabad MSC, if I am making a call to somebody, some X, so my network has to, for example, I feel that myself and that X is located in the same PLMN. So what happens is, to know the situation, or where the customer X is located, so that triggering will happen through the HLR, and this kind of phenomenon, in the sense, all the signaling databases interaction with the signaling databases like HLR, VLR, or AUC, EIR, in the case of prepaid, IN, everything will be done through the MSC only. And here the MSC, if it is working as a gateway functionality, so in order to have call management and inter PLMN to interconnect different PLMNs and PSTN, then we call that as a gateway MSC. Now MS is also doing some interworking functions. So interworking function is nothing but the protocol conversion when it comes to the mobile GSM data terminal to the landline data terminal, data equipment, right? So, and one more thing is, the important function is echo canceller. Echo canceller is, whenever we are making a call to the PST number, so normally a echo will be generated because of the GSM delay, right? So if because of the delay, what we are going to hear is, we are going to hear something like an echo. So in the MSCs we place the echo cancellers, and because of this echo cancellers we are avoiding that echo part. Now coming to the HLR, home location register. So now what happens is, let us go with the practical mode. See, whenever you are taking a SIM card, normally every SIM card is having the permanent identification number, what we call up the IMSI, International Mobile Subscriber Identity. Now you are taking a SIM card, and in a CSE you are opting for a number. For example, your number is there. If it is appended with a +91, the country code, so then it will become an MSISDN number. So what you are doing is, you are choosing a number, what we call as an MSISDN, and that MSISDN is mapped to IMSI, and you are taking such kind of service, whether you are talking about the prepaid or postpaid, then you are opting for some facilities. So this together, the IMSI which is been there for you, and the MSISDN which is allocated to you, and the kind of service or facilities, all together we call it's a subscriber profile or the customer profile. So this is a subscriber profile. Now in order to activate your SIM card, this profile has to be updated somewhere or inserted somewhere. That register we are calling is an HLR. So now the HLR is storing, right? It is the storing the profiles of a customers of that particular PLMN. Now, for example, AP BSNL is there. In AP BSNL, if you find one HLR, if you are taking a SIM card of AP BSNL, so your complete profiles are being shared in the AP BSNL HLR. Okay, so that is one point. And whenever you are registering, whenever you are updating your location in a particular MSC, so as I said, every MSC is having its own VLR, then that MSC triggers the HLR, and it says that this particular customer is updating his location in my MSC area, in the sense he is registering in my MSC area, then that HLR will be updating that MSC or concerned VLR number as a temporary record in that HLR. Similarly, as far as the data aspect is concerned, so whenever the customer updates the routing area, so that SGSN number will be forwarded. The SGSN triggers the HLR stating that this particular IMSI customer is updated routing in my SGSN area, so that the SGSN number is also been updated here. And at the same time, there are some keys are there, ciphering items like KC, ciphering key, SRES, signature response for the authentication center, and random number generated by the authentication center is also been stored here, right? Now, the main purpose of the HLR is to store some information of the customer. One is the permanent information, the profile of the customer, and at the same time, it is holding some temporary records which is related to the subscriber, which MSC he is moving, or roaming, on which SGSN he is roaming, in the sense in which VLR he is roaming and in which SGSN he is roaming, and at the same time other ciphering items. Now coming to the VLR, see, whenever I am registering in a Hyderabad MSC, for example one MSC, now what happens, so there is a VLR inside that MSC, VLR is a part of that MSC. So whenever it triggers, as I said in the last slide, whenever it triggers and ask the HLR to update that particular MC subscriber is roaming in this particular VLR of mine. Now what happens is HLR sends the profile of that customer to this VLR. Now what happens, a profile will be copied, the customer profile is copied from the HLR to the VLR, right? Now the VLR is also updating with the profile of a customer. Then what is the reason to update the profile of a customer in the VLR in a sense? Now assume that we are having a number of MSCs inside the VLRs, and everybody is raising some requests, for example voice call request and all. Now assume that I am a calling party and somebody else is there as a called party. So whenever the calling party is making a call to the called party, now calling party subscriptions has to be verified. For example, if you are making a call, so the network has to verify that you should have a subscription, and at the same time prepaid, postpaid connection. If it's a prepaid connection, right, your profile has to be verified again. If you are making an ISD call, so you should have the ISD facility and all, right? So now in the one PLMN, millions of customers are there. If everybody is triggering the HLR, every MS is triggering the HLR to know this information, so now normally what happens, HLR will become loaded like heavily. So that is the reason a profile is being copied into the VLR. So the persons who are roaming under that particular MSCs can trigger that information of the calling party to that with the particular VLR, so that we can deload the HLR. That's the reason to copy the permanent record over here. Now at the same time, as I said, some location identities, just like when the subscriber is registering in a particular MSC, so the MSC will be knowing that which global cell identity, right, he is he is roaming, and at the same time the location area identity, in which location area the subscriber is roaming, and this kind of all the information will be stored as a location identities in the temporary record of that particular VLR. And at the same time, so this VLR assigns at the time of location updation a dynamic number called TMSI, temporary mobile subscriber identity. It's a 32-bit number, and this temporary mobile subscriber identity is allocated by the VLR at the time of location update process beginningly. And at the same time, a periodical location update process also happens by the MSC in order to know the liveliness of the mobile station. At that moment also the TMC will be reallocated, right? So there are two conditions are there. One thing is at the beginning time, and at the same time periodical location updation times also TMSA is allocated. And another function of the VLR is assignment of the MSRN number, mobile subscriber roaming number also. So when that MSRN will be allocated, so for example, if somebody else from another MSC is calling to me, I am situated in Hyderabad MSC. If somebody else calling me within the same APPS, PLMN, APBSNL, assume that one of my friend calling from the Vijayawada. So we are in the same PLMN, right? So at the moment that MSC doesn't know where I am located, and at the moment that Vijayawada MSC is triggering the HLR and asking that, you just let me know where this particular number Srinath is located and all. Now what happens with the HLR looks into the database and it finds that this particular IMSI person is roaming in Hyderabad VLR. So now the HLR will trigger the VLR. It sends a request to allocate a roaming number and given an acknowledgement. That's what we call as a provide roaming number request. Now, whenever VLR receives, say, this request, PRN request, now VLR assigns an MSRN number, which is available with its pool. Every VLR is having a pool of MSRN number. Out of that pool, it assigns one MSRN number to the particular customer, like me, and it sends that same MSRN number to the HLR, and in turn HLR will give that MSRN number to the MSC. Now Vijayawada MSC will understand with the routing tables, MSRN routing tables, it will understand this particular customer is located in Hyderabad MSC. Now the call will be routed to the Hyderabad MSC. Now as soon as the call is routed to the Hyderabad MSC, now the Hyderabad MSC will take that information from the VLR. अरे यार, it asks the VLR, अरे यार किसी बंदे को तुमने MSRN दिए थे, allocate किए थे, so could you please tell me for the which person you are allocated that MSRN number. Then the VLR is providing all the details of that particular of mine with the location identities and everything. Then MSC pages a call to me so that I'll get a incoming call. So that is the functionalities of the VLR. So where it is coming, VLR is storing the permanent record and the temporary record. In the temporary record, it storing the location identities, and it allocates in TMSI, and it is allocating the MSRN number. And apart from that, in order to happen the deciphering process, and in order to check the authentication parameters, so whatever the parameters has been shared by the authentication center, like KC, SRES, and random number, is been stored in the VLR also. Now coming to the authentication center, so authentication center is meant to have two functionalities. Now authentication center will perform the two parameters. The use of authentication center is to check the authenticity of the SIM card, and another functionality of the authentication center is to happen the ciphering in the network. Okay, for that reason, it will be having KC, random number, and A3, A8 algorithms. So there are A3, A8 algorithms are there. So now what happens is, using that actually the security key and this A3, A8 algorithms, the same will be provided in the SIM card of the customer. Now authentication center, what it will do, on the request of the MSC, just like an authentication process. So MSC sends a request to authenticate the SIM card. Now authentication takes the concerned KI value of that particular customer and taking a random number and using some A3 algorithm, so it generates a signature response. Fine. And at the same time, using a A8 algorithm with a KI with a random number, it generates a KC, ciphering key. So what is the dynamic number it has chosen? It has chosen some random number, and using the A3 SRES and using A8 KC, it has been generated, and that SRES, KC and random number has been shared to that MSC. Now what MSC will do, so it will keep that SRES, the KC in its VLR, and the random number is passed to the mobile, and it asks the mobile to generate that SRES, and it asks the mobile to generate the this encryption and all. Now what happens is, so now using that random number, using the same KI value provided the random number by the authentication center, which received through the MSC, the mobile will generate using the A3 algorithm, same signature response will be generated, and now that signature response is will match at the MSC level. So if the both are matched, then that's network can feel that that authentication process has been done, and we can feel that the SIM card what the customer is using is a genuine one. And similarly, the KC is generated using the A8 algorithm, the mobile, and using that KC and the frame number, it generates some ciphering bit stream, and that ciphering bit stream and our encoded user information is multiplexed and modulated over the air, and this is what ciphered information we are able to reach it to the network. And using the KC again, which is available with us, right, the deciphering process will be done in the network. Now coming to the equipment identity register. So it is used to validate IMEI, IMEI of a handset, International Mobile Equipment Identity. So if somebody is being complainted, all the complainted are reported to be stolen, are being put under a blacklist, and once the IMEI is put under the blacklist, that IMEI handset will not work in that particular network, and which is reported if you wanted to track or if you wanted to trace that IMEI. So those will be put under the gray list, and the IMEI which is put under the gray list can be tracked or traced. Now coming to the white list, which is not reported anything, that IMEIs are being treated as a valid one, and they'll be in the white list. Now coming to the functions of the OMC, so included together OMC R or OMC S. But the only thing is, now here all the functions which is related to the alarm management, fault management, remote handling, performance management, or configuration management, this is with respect to the BSS part, the OMC R is taking care, and with respect to the NSS part, so OMC S is taking care. Now coming to the GSM identities, so let us discuss something about the MC, International Mobile Subscriber Identity. And this international mobile subscriber identity should not exceed the 15 digit, and it should comprise of MCC plus MNC plus MSIN. So MCC is nothing but the mobile country code, MNC mobile network code, and MSIN mobile subscriber identification number. Now as far as India is concerned, MCC is 404, and as far as APBSNL is concerned, it's a 73, like that. So here the rest of the number is it goes to the MSIN. So included all, it should not exceed the 15 digit. And coming to the IMSI, IMSI is a very, very important identity, and this is an identity given to the user to identify in the network. Okay, IMSI is an identification to identify user in a network, and MSISGN is an identification given to the common people to identify a user. Alright, so now again IMSI, and IMSI will not be shared on radio part. It will not be shared on the radio. Only IMSI will be shared only in the beginning time, but rest all the times the IMSI will not be shared, and that is the reason we are allocating a TMSI. So we'll assume that something like we are having our own names like IMSI. So whenever I am registering to a particular course and in a college, normally I will be allocated a rule number, isn't it? All the announcements and all the information will be passed using the rule number. Similarly, just like a rule number, a TMS has been shared, temporary mobile subscriber identity is been assigned or raised. So in order to assigned by this VLR, in order to share all this kind of informations, rest all the informations. So why the TMS? In the sense to have the confidentiality and the security reasons. So as you can assume that same thing, if you are writing some examination, so on a paper, if you are writing your name, that is not good practice, isn't it? You should not supposed to write your name, because in order to keep it confidential, right? So you need to write only the roll number. That's the reason. Same thing. So now coming to the MSISGN, it is having the country code followed by the national significant number, which is nothing but our mobile number. So as I said, it should also not exceed the 15 digit, and this is an identification given to the common people. Now coming to the MSRN number, we already discussed. So this is assigned by the VLR on the demand of HLR, so on a per call basis. Okay, and coming to the MSRN number, it is having the same structure like MSISGN. So every VLR is having a pool of MSRN number, so that our MSCs are having the MSRN routing table, so that it can identify which VLR is been assigned that number, so that it can contact the particular MSC. Coming to IMEI, International Mobile Equipment Identity, is a unique identity, has been burnt in that particular mobile handset during the fabrication by that particular company. Okay, so that is about this basic session. Thank you one and all, and if you have any questions on the queries, you can reach me on my mobile or by my mail ID which is given in the presentation. Thank you one and all.